Today we're taking a look at this thing called the graph translation theorem. Now, if you remember back to geometry, those were the days. A translation was simply a slide in the coordinate plane. There was a translation rule, and that rule told you it to slide all the points in that figure horizontally h units and vertically k units. Well, the graph translation theorem does the same thing, but it's going to slide a graph or a function or a relation in the coordinate plane. And it simply says this: in a relation described by f of x, the following two processes are the same. Replacing the x in the function with x minus h, and replacing the y in the function with y minus k. Now, doing this essentially applies the translation t sub h comma k. In other words, it slides it horizontally h units and vertically k units. So if you take a look at our geometric example here, this translation slides the points 1, 2, 3, 4, 5, 6 units to the left. So that's -6 for our h, and down 1, 2, 3, 4, 5. That's -5 for our k. So this translation would simply be written as t with a subscript -6, comma -5, indicating the horizontal and vertical movement. So let's see how these translations affect graphs and how we can quickly find the equation of these functions. Before doing so, let's talk a little bit more about parabolas. Remember, a parabola is simply the graph of a quadratic equation. That quadratic equation takes on this form of y equals a times x squared, sometimes ax squared plus bx plus c. Its vertex for right now is always going to be at the origin. Okay, so 0, 0 is either its minimum point if that parabola opens up when a is positive, or it's the maximum point when that parabola opens down. In other words, a is going to be less than 0. So here, for example, we have y equals -x squared, and over on the left we have y equals just the positive x squared. All right, let's take a look at our next example here. It says to use Desmos to graph this function y equals 1/3 x squared. So a couple of different ways you can do this. You can use Desmos, you can use your graphing calculator, you can make some tables such as x and y, plot some negative values and some positive values, and you can then plot those points. Well, I know that it's going to be centered at our vertex. If I put 0 in for x, I get 0 for y. When I put 1 in for x, I'm going to get 1/3 for my y value. 2 in is just slightly over 1, and my next value, 3, if I put 3 in, 3 squared is 9, 1/3 of 9 is 3. So I'm going to plot that point here and here. So I have enough points now to kind of make my parabola. I know that it's going to open up because my a value here is positive. And I want to now create my line of symmetry. My line of symmetry, or my axis of symmetry in this case, is the y-axis. So that is the line x equals 0. And that vertical line that if I reflect this graph over that line, it will fall on top of itself. So that's the reflection line. Now I also want to plot my vertex point, which I already did. That vertex point is here at the origin, 0, 0. And because my parabola opens up, I note that this is a minimum point. No point on the graph exists below it. It is the kind of the valley between these two hillsides. All right, now let's take a look at example 2. It says we're going to consider this same parabola. Here is the graph of y equals 1/3 x squared. And we want to now translate that graph by moving its vertex from 0, 0, 3 units, 1, 2, 3 to the left, and up 1. So we want to give the translation and then find the equation. So let's start by giving the translation. Because I moved it 3 units to the left, that's subtracting 3 to all of my x's. Now that means my h value is -3. My k value is +1 because I slid it up 1. So here's my h and here's my k. If you want to, go ahead and just designate h as -3, k is +1. Now, we also want to give the equation of that image parabola. So notice that the equation for the original is y equals 1/3 x squared. We said that we could produce the same result if I replace y with y minus k. So if I replace y from my original equation with y minus k, then I'll have y minus 1 is equal to, and then I'm also going to replace x with x minus h. So here I go, I'm going to put my 1/3 out in front, and x is going to be replaced with x minus h, which is -3. And again, I have to square that. So let's simplify this a little bit. I have y minus 1 is equal to 1/3 x plus 3 quantity squared. Now we should always solve our equations for y. So let's go ahead and solve for y by moving that -1 over to the other side. And when I do that, I get y equals 1/3 times the quantity x plus 3 squared plus 1. And here is the equation for my graph here that gets shifted 3 units to the left and 1 unit up. And if you were to graph this equation here on Desmos, this is exactly the graph that you would get. All right, let's take a look at example 3 now. Example 3 says, given this function, this is our absolute value function, we want to graph the image of the function under the translation 6, -2. Then give the equation. So again, I'm going to list my h here as +6 and my k as -2. This tells me the direction in which to move it. So I remember the absolute value function. Its vertex was at 0, 0. So if I move to the right 6 and I move down 2, I can plot the vertex of this new function right here. And I also know that the branches of that absolute value function go off at this 45-degree angle. So I'm just going to go ahead and graph that. It's going to fall through these points here. If I can draw those nice and straight. And so here's the graph of this translated function. Now let's come up with the equation for it. So remember, here's our original equation, y equals absolute value of x. I would produce this by replacing all of my y's with y minus k. So y minus my k value is -2 should be equal to the absolute value of x, and I'm going to replace all of my x's with x minus h. So here's my h value is 6, so it's x minus 6, and then put down my absolute value sign. Okay, again, we should simplify this. This becomes y plus 2 is equal to the absolute value of x minus 6. Let's get y by itself. Y equals the absolute value of x minus 6. I'm going to subtract over my 2, and here is the equation of the graph that we just plotted by translating or sliding the absolute value function to the right 6 and down 2. Go ahead and check that on Desmos. Plug that into your graphing calculator or Desmos and see if that's not the graph that you get. The vertex should be at 6 over and 2 down. All right, let's run through a handful of examples now, making sure that we can give the translation that's taking place on the function of y equals a times x squared. And let's also try to find the coordinates of the vertex and give the equation for the axis of symmetry. And it's okay to use Desmos here to help you out. All right, so feel free to plot a few of these using Desmos and answer these questions. Now remember, we're always going to replace y with y minus k, and we're going to replace x with x minus h, and that's the equivalent to doing a translation of t sub h comma k. So notice y got replaced with y minus 6, so my k must be +6 here, and my x got replaced with x minus 8, so my h must be 8. So my translation that's occurring here is 8, 6. I'm shifting it or sliding it 8 units to the right and 6 units up, which means my vertex needs to be slid 8 units to the right and 6 units up, and that vertex will occur at 8, 6. Now my axis of symmetry is that line that cuts the middle of that parabola right in half, and that's always going to be found at x equals h. So my equation of that line is the vertical line, x equals 8. All right, let's take a look at our next one here. We have y equals negative, and then in parentheses, x minus 1, quantity squared, minus 3. So this negative out in front here really doesn't mean anything for me right now. I see that x is being replaced with x minus 1. That means my h must have been positive 1. And my k, if I were to bump this guy back over to the other side, I would have written y plus 3, which means it was really y minus a negative 3. So my k value here would be negative 3. So I'm translating this by moving it right 1 unit and down 3. Therefore, my vertex will be at 1, negative 3, and my axis of symmetry will be at x equals positive 1. All right, let's take a look at another example just like that one. If I had this negative 4 here and I bump it back over to the other side, I'll have y plus 4, which means it was really y minus a negative 4, and that makes my k value negative 4. So my k value here is negative 4, but my h value now is found inside here, and you'll see that it's x plus 3. So that really means that it was x minus a negative 3. And therefore, negative 3 needs to be my h value. All right, so that means I slid this to the left 3 and down 4, and therefore my vertex should be at negative 3, negative 4. And my axis of symmetry should be at x equals negative 3. All right, let's try one more, and then we'll leave the last one for in class. We have y plus 5. So my y got replaced here with a y minus a negative 5. That means my k value is negative 5. And x got replaced with x minus a negative 1. Therefore, my h value is negative 1. So my translation looks like negative 1, negative 5. And therefore, my vertex is also negative 1, negative 5. And my axis of symmetry is x equals negative 1. All right, try this one on your own. See if you can come up with it just using the letters for your translation, your vertex, and your axis of symmetry. One final example for today, we have the equation of y equals negative 1/2 x squared. It's translated so that the vertex is at negative 3, 2. That means I moved left 3 and up 2 in order to graph this new equation. I want to find that equation for this parabola. So again, my h, if I'm thinking in terms of my translation, my t sub h comma k, I went left 3, so that's negative 3, and I went up 1, that's positive 1. So I'm going to replace x with my x minus h. So here we go. Here's my equation. In the first place, I have y equals negative 1/2 x squared. I'm going to replace x, negative 1/2 x minus my h squared. And I'm going to replace y with y minus my k, so that's y minus 1. Now I should simplify things. I have y minus 1 is equal to negative 1/2, and this is x plus 3 quantity squared. And I'm going to move my 1 over by addition. So my final equation here is y equals negative 1/2 x plus 3 squared plus 1.